So guys, now we're going to do our 13th project, that is Titanic survival prediction. So we have some data sets, and based on the data sets we have developed a machine learning model that helps us to predict who are the survived in Titanic and who is not. Okay, so that is a simple model that we have implemented here, and at the end of the day, the main thing of this project that we will learn here how to implement the cross validation, the thing that already we have learned in the theory part. Now let's see how we implement that thing on the direct data set, okay, to help us to increase the prediction rate. Okay, so let's see. So let's go to our folder. Okay, that's our folder, and I have already created in that same file. Okay, so let's see the first data set. What is the look like our data set? Yes, as you can see here, the passenger id is the first column is, then the survived column, it's our target column. 0 means who is not survived and 1 means we got survived. And the class level, this one, then so the name of that passenger. Okay, name of the passengers, then sex, its age, it's such kind of various such kind of categories also here. That's ticket number, fare, cabin, payment mark. So that's the set that we have collected from internet, and I am giving the link of that particular data set in the description. Now goes to the Jupyter notebook. Okay, that's our folder. So on the Jupyter, let's create a Jupyter notebook file first. Let's copy the name. Now let's see the agenda of the today's project. So first we are going to load the data and test and training data sets that are already given, and then we have some prepare the data to apply the machine learning model. After that, after preparation we will simply apply the machine learning model. Then after predicted that thing to increase the prediction rate, we will apply here the uh, uh, cross validation model. Okay, let's see. This is the first section that we are going to achieve. Okay, now after that we have to that load the training and test data. Okay, in that folder I have already pasted that link, pasted the folder training and test data. So let's load it. For that loading we have to need that pandas data frame. Okay, then we have to take another train model as pd dot. It's, guys, you can see it's the csv file, both of the csv file. So read csv. And the folder name, file name is train.csv. Similarly, test dataset also, let's copy it. Okay, now let's see that the training file first, train file. Okay, these are the train file that already we have seen, and you can see here, guys, there have 891 number of rows we have. Okay, and that 12 attributes, 12 column we have, and our target column is the survival column. The second column is our target column. Okay, and rest of the columns, so I'm not needed here the rest of the column. We need something, some text column we needed, some age support. So let's take, when we develop that model then you will understand. which column? I am not taking 12th column here, so I am taking the main 3 4 column I will take here, and as your requirement you will increase that attributes in your own. Just take it as your homework and apply in your own your home. Okay, so let's see how many attributes they are having in test data. Yes, 418 number of rows it has, and 11 the test. So guys, you can see here the test data there have no uh, survived column. Okay, but in train data, in the train it's at the survived column. Okay, so it's a survived is our target column actually. That's for this main reason. Now let's check is there a null value or not. Let's check it. So man, let's play with the train data first. Each null, and apply the sum. As you can see here, in the age column, they have 177 null values, and in the cabin column they have 670 null values. Okay, and embark in this column we have 2 null values. Okay, let's remove that thing first, we don't need. So first let's check also for the test data if there has any null value or not. Yes, it's also for the age column, it says 86, cabin column 327. Okay, so these are the 2 main column, there have the null values. We have to define that 2 column first. So to refine it, we have to go to the data preprocessing step. Let's copy that name. Okay, now let's see some statistical value of that training and test column. So here guys, you can see in the age column there have 86 null values, in test and in for train it has 177 null values. So let's see its median value, how much median is. So need value, let's take the data set, which column, age column it is, and take its median. So if we see 28 its median value. Okay, similarly let's count that the train age. So actually just guys, I have taken that median value. Now in that place of null value, I'm going to place that median value. Okay, so I think you'll understand what is the idea. So guys, in the data sets guys, you can see in the data set, suppose let's this column, this column here, in 88 number of rows there have null value. Now first I am computing the median value of that age column. Now I am putting that median value on this null, on this place, everywhere where we got that in. Let's do that first. Let's copy it. Okay, now we have to fill where we got that in value to that median value, we will fill it. Okay, so similar case also we have to do for the test set. Also we have to done same thing. If you're interested, then you can take also the average value, not so as depends on you. Here I am taking here the median value. Just take it as your homework. Just take it average value and train that model. Then you see the differences. So it's depend on the situation to situation, model to model. Okay, let's run it. Okay, now where cabin is also not needed to train that model. I am not taking that cabin column. Okay, so now we have to do one thing, guys. You can see here, does take the sex. If you see the sex column, there have the two attributes, male and female. So for that, since it takes data, it's a text data. First thing that you have to do, you have to convert that, you have to encode that text data into some numerical value. So let's use that one hot encoding here, because only two attributes, I think we have the two or three attributes have. Let's see it first. Okay, as you can see 191, here I have to take that value count. So what, okay, let's see how many unique value there have. Actually it's, I have to take that column first. I have to take that sex column. Then you have to take that value count. What happened? Sex is not defined. Capital X, I think. Yes. Yes. How many? 891 columns. Columns there have. So why it's not taken value count? Shall see. Let's see. Unique. Okay, as you can see here, if I take that unit, so here that male and female, only these two unique value they have. So for the other ones we have to encode that one. So let's encode it first. So I have to make a new column, train. Name is, suppose let's each female. Yes, if it is female, then we have taken as type. Okay, if this equals to female, okay, I have to pass it as string and have to convert it as type integer, suppose, because only two there have as integer. That's all. Similarly for text data also you have to do. Text data is female, then as type init. Okay, let's run it. Yes, now guys, you could, if you see that one at train column, then you'll understand. Yes, if is female, then it's as filled by 1 if female, otherwise it's 0. That's things also you can see from the test column also, test dataset also. Let's see the test dataset. Okay, as you can see here, same thing. Okay, now guys, so now let's go to that. I have done that 100 encoding. So now let's take that which column I have taken here for the training the model. Okay, let's take it. So for training here I have taken that prediction column COL. Let's take here for attributes I have taken here the class level. It's also important. Passenger ID, I think it's not so much important. Class level is important. Attributes, let's second one I have taken the is female or male. Is female means this column, that is I have encoded. Let's take third one. Let's take the age, and let's take I think hair is important also. Let's take fair also. Okay, I've taken here these 4 attributes. So if you find if you're interested to take any otherwise, so you can take it the name. You can to apply here. You have to convert this text into some vectors. You can use here pfid vectors, what to vectors, any as your requirement you can use. So just I am taken for that building that model. I have taken that only these 4 attributes. Okay, so just take it as a homework. Just add that attributes and do it yourself, guys. So let's first train the x-train. Let's define the x-train. So this x-train now will be what? This train and that column that we have defined, and have to take its values. Similarly for text also, text also, text column values. Okay, that's now let's define that y train will be what? Y train will be train this column. We need this is train to take the test. Sorry, it's train. Let's say we have to survive. This is our target column. We have to take it as a y train. Okay. Okay. Now let's see what is the look like our train value. Yes guys, you can see these 4 attributes that I have taken. And similarly, if you want to see that y train, these are the y train value. Okay, I think you'll understand. Let's remove it. Let's now apply the ML model. Now we have done that splitting thing. Now let's apply the machine learning model to predict. Now we have to on the third section. Let's make it as heading. Let's run it. Okay, so first we will apply the logistic regressions. After that we have seen its prediction value, then we apply its the cross validations, and we will see the predictions. Is it improved or not? So let's try using the different model. Let's play with it. Okay, so first let's apply the logistic model. We have applied the escalon. In the escalon, we have that logistic model intersections of the linear model. So import that one. Logistic, what it is required. Suppose let's have used here the logistic regression. So let's call that our model logistic regression. Okay, make it as a function. Okay, so let's feed the model now. Model dot feed. So first we have to pass it the extreme data. Then we have to pass that y train data. Let's train that model. Yes, we have done. It's simple, guys. It's a linear model. We don't need here the so much time. Now let's see the prediction score. What is the prediction score? So y predict. Y predict. Let model have to take it that predict. Okay. Now which data set we are interested to predict here? That test data set. Yes. So what is the text look like? If you see, yes, these are the test data look like. Let's apply that test data. What happened? Input contains NA in infinity or to large value. It's data type. Okay, guys. Because you will see here in the test data set, in the pair, there have one null value. And I am included here the pair sections also. So for that reasons, we have to drop that one. Okay. In the text data set. So let's drop it. tst is equals to tst dot drop na. Okay, that's all. Now just see that. Yes, now I have rectified all that issue. Now let's again here make it. Let's run it on that running model. What happened? Okay. No problem. We'll take here. We have to run this one. Okay, let's run from first. Yes. Drop test sum. Yes. No. Train sum. First let's run the train sum. Yes. Okay. Because for the test set we have removed all the null values. Now next data preparation state. Yes. Now I have to compute the median value. Yes. Now I have to take. Yes, no problem. Now I have to see. Yes, female as type. We have encoded it. Now you want to see the train data. Okay, if you want to see the test data here, also you can see. Let's see the test one. Yes, this is our test data. Total 87 rows there have on our test data. And on the train data, how much? 10. Okay, guys, one thing that I have done here, when I use the drop in, most of the rows are the removed. Here, guys, you get 191, and if you see the test data, there have 418, and on that 418, see that one, 327 number of null value they are have on that cable section. So only we have to drop that pair when there have null value, drop in it. So test now will be equals to test, only we have to remove that one, test dot taken at the pair. So test pair is equals to drop in it, that's all. Drop in. Let's run it now. Now guys, you can see if I run it in the pair section, okay, so what's problem, why it's not going? Pair value I have dropped in the pair section. Okay, let's see more closely. So guys, instead of drop in, we have to change that code. So let's check test dot, we have to take the test and we have to use that drop in and a subset will be which subset will be which column. We have interest to just see that we have to pair. Okay, that's all. Let's run it. Yes, now if you check pair column, in previous pair column there have one null value. Now let's check. Yes guys, we have removed it now. Okay, that's all. Now our pre-preparation, it's all unique value, that's all. Yes, we have done that encoding part. Now right, yes, okay. Now let's train that model. Yes, done. Now let's predict it. Yes, sure. If you print that prediction, then you will see. Yes guys, that's the other predicted value. Okay, I have used here the X test, but in our X test there have no such survival column. These are the predicted value. Now let's see what are the accuracy of that model. This is the thing. Let's see the accuracy. Model dot what happened? Model dot prediction accuracy is take, and which is our that target column. This is our test column, and how we'll calculate the prediction, guys, because in that X test set there have no such survived column. So it's not possible to find our prediction value on that model. Guys, I think you will understand. Just see guys, and the just if you want to count that what is the prediction accuracy value, then we need that y test value also. But in that case, in our case, we have no y test value, only y train value we have. Okay, this is the x test. Y test also we needed, guys. We have no y test value. So let's find the accuracy of the training score. How much accuracy it's keep? I think it will be give that 100%. It's not needed because we have fitted this using this two one. Although let's see. So logistic regression is new to accuracy. Okay. As on that model, there have no accuracy value. Okay, no problem. Now let's implement that cross validation. Then after applying the cross validation, we will see. Let's implement that cross validation. So we need here the apply cross validation because guys we have no such a test value. Why test value we have not? For the other decisions we have to apply that cross validations and we will justify that thing. Okay, so let's apply that. So one module also we needed to apply that cross validation module. You have to import from here. Logistic regression, cross validation. We need it. Now we have to make model. It will be cross validation. Suppose let's that I have taken that cross validation value 10. I have applied here. So now let's fit that model. Fit it, and where you have to fit it as our x train and y train. I think I have copied this one. Yes. Now let's run it. Yes, it's done. Now let's see that cross validation score. Was it or what is it? Let's see. So yeah, not in that library there have no. Let's see that model selection. Here cross validation score we have to take. So we have two models. First model is equals to what? We have the model is equals to cross validation, logistic regression that we have made this one. This is our first model. And here we have taken that cross validation value 10 that I have used here. 10. Okay. Now let's compute that score. Our model and train data and test data. White train that we are going to apply. And let's apply here cross validation. Suppose let's I'm applying that 5. First guys, I have applied that model, train that model using that parameter C. Just see that one. Then you will understand what is about that C. C is the inverse of the regularizer strength. Okay, we'll already learn in theory part what is the strength of the regularizer high to. It is the regularizer tuning. You have to choose that value. Okay, I have taken here that in default it's taken 10, so let's make it as default. After seeing, we will now let's see that cross validation score here. Sorry, it's small, it will be so small. Now let's see that score. Yes, so it's improved, guys. It's improved, you can see here. So let's 5-fold cross validation I have taken here. Let's take 10-fold cross validation, then we will see. It's after 4 it is decreased. So 4 is better. Let's see again 10. Yes, on that this is the sample score of that our model. Okay, but you can ask, so what is the importance of that one that I have taken here, model dot cross validation. So if I use that model dot cross validation cv model and the cross validation score, then we'll see it takes some time because first it's cross validated as mod. Yes guys, you can see here these are the, because already it's had the cross validation model. So let's try to find here that prediction value. It's the cross validation. I have taken that parameter 10 here cv. Just see that how much fold cross validation we are going to be used here. What is the significance of the cv? You can determine the cross validation splitting strain strategy. Okay, how much data set it's divided, that's the simple thing. Here if you see that argument, here also the same model. Okay, so that's all for today. That's, you can see this is the, if you simple apply that logistic regression model, then you can achieve here from using it that up to 83% accuracy you can achieve from here. Okay guys, I think from this lessons you will learn something how to apply the cross validations. So and when we will apply that kind of things, we will directly learn that thing in the theory, but I think you'll understand on the practical sessions how to apply that cross validation. Okay, so that's for all today. So see you some next video, next topics. Okay, till now, bye.